Hello, this is part 2 of our series on object-oriented development for MQL4, where we'll build on what we did in part 1. If you haven't seen the part 1 video, I've included a link in the description and on screen that you can follow to see that. If you are not familiar with object-oriented programming, I recommend watching that first. Something to clear up from last time, because the classes we created were very basic. There is nothing that you can do with object-oriented programming that you cannot do in traditional ways. It doesn't create any access to new features of MQL. There is nothing new that can be done with it. So the benefit of object-oriented development is not what you can do, but in the way that you can achieve it. And we should see some benefits with today's examples. Inheritance can be used where a class or a type of object can be thought of as a subset of a more generic type. It allows common features to be encapsulated in a base class and still leaves the opportunity for the customization of those features in lower level classes. That should all become clearer with the demonstration. First thing I want to do is create a base class. I have here the class that I created last time, the CCI Donchian Channel. It has most of what I need for a base class already, so the easiest thing to do is just to make a copy of that. I just open this folder. Now I have the base class, which is just a copy of the Donchian channel. First thing to do here is to update all instances of this class name to the base class name. Now I move on to the member variables, and I will keep the member variables that are going to be common to channel classes, and I'm also going to make these part of the protected group. Variables and functions that are protected can be used directly by child classes that inherit from this class. So the common information should be in the protected space. Now I want to maintain the symbol and the time frame because those are going to be common across classes, but the bar count perhaps not. I don't want to be too specific. So I'll remove that. I can retain first bar time, the high and the low. I'm also going to add a midpoint to the channel. This has nothing to do with creating a base class, but most channels do have a midpoint, so I'm going to add that in now. I still have my previously calculated, but I'm also going to make the update function virtual, and I'm going to add a second function, update values. The purpose of that will be clearer as we move through and update the rest of the code. Moving on to the constructor, I'm not making the bar count part of the common base class, so I can just remove that. And I can remove the same thing from the init function. And as I've added the mid channel, I'm also going to include a function to return the mid value. And I'm also going to make all three of these functions virtual. If you look up virtual in the MQL help, the answer is tells the compiler that this method should be placed in the table of virtual functions of the class. It's not a really helpful description. What really happens is that at runtime, the function will be executed from the lowest level child class that implements that function. So if I have an update function in the base class and an update function in the child class, then at runtime, the update function from the child class will be run in preference to the update from the parent class. It'll be easy to understand as we go through the example further. Here in the default constructor, I again don't need the bar count, so I can simply remove that, because this init function in the base class just takes symbol and time frame. In the specific constructor again, I can remove bar count. And remove that from the call to the init function. Here in the init function itself, again remove the bar count argument. Keep the symbol and time frame settings. Remove bar count here. These two are the same. Again, as I've added the mid value, I'm going to set the mid series, the mid array as a series. And I'm also going to remove the call to update from here. Update calls like this, where I'm doing an initial run, should be done almost always in the child class rather than in the base class. So I'm just going to remove that. Also, because I've added the mid function, I'm going to add another function here with the high, the low, and add the mid to that. Then we move down to the update function. Now, a lot of the code in here will be common to any channel calculation. I need to know how many bars I have. I need to know if this is the first time through, how many bars I'm going to calculate this time around. All of this down to this point would be common to most channel functions. But the code here, where I'm actually calculating the values, is obviously going to be specific to that channel. So I'm going to remove that from this update function and replace it with a call to the function that we haven't written yet, update values. And now I'm going to add a default update values function, which does nothing more than set the previously calculated bars to the number of bars. I also forgot to add the arguments here to pass in the number of bars and limit. I could recalculate those in the update values function, but given that I've already done that work, it's much easier to just pass them in here. Now that I have a base class, I need to inherit from that in the ATR Channel class that I already have. First thing to do is add an include statement to bring in my channel base class file. Next, I want to indicate that CCI ATR Channel inherits from channel base by adding :public CCI channel base. The public statement here means that any functions of CCI channel base that are public can be used by any program that creates a copy of CCI ATR Channel. Without that, even the public functions inside CCI channel base can't be accessed from other programs, although they can still be accessed from the ATR Channel class. Now I'm going to remove everything that I made common in the base class. I'm also going to just change the name of this bar count to ATR periods. That again has nothing to do with classes and inheritance. I'm just doing that to improve readability, given that we're about to create another class that also implements a channel. I'm also going to add the definition for the new update values function. And the update function, everything that I need the update function in CCI ATR Channel to do has already been done in the base class, so I can remove that completely. Now there's no change to the constructors. I still have a default constructor that takes no arguments, and I'm still taking all 3 arguments in the main constructor for the ATR Channel. But the init function does change because I'm not going to use the initialize here to set the symbol and time frame. They are done in the base class. And again, I'm going to update bar count to be Donchian periods just for readability here. The functions for high and low value and the new function for mid value are also part of the base class, so I can also remove these from the definition here. In the default constructor, I do want to set the number of periods, but there is no need to set the symbol and the time frame. By default, when the default constructor is used, first the application will run the default constructor for the base class, which will take care of setting the defaults for symbol and period. Then it will run this default constructor, which will set the number of periods. The main constructor does change significantly. I'll just put the revised constructor above this to show the difference. So I've got the same arguments being passed in, but I've added colon CCI channel base symbol time frame. This will call the constructor of the base class first, passing in the symbol and time frame that were passed here, and then all I will need to do is initialize with the number of periods being passed through. And that's my new constructor. So again, I'm leveraging the work that's already done in the base class. Then to the initialize function, we've removed symbol and time frame as arguments to this, only passing in Donchian periods. Symbol and time frame are handled in the base class as first bar time prev calculated, setting the arrays as series. But here I am leaving the update function because as the child class, this will perform the first time update to gather values. And remember that there is no, or when I finish, there will be no update function in this class. The only update function is in the base class. I also don't need the high and low functions. They're also in the base class. The update function here is no longer needed. All I really need to do is this piece of code that calculates the actual channel values plus the new mid channel. So I'm just going to replace all of this. With the update values function. Takes bars and limiters inputs and calculates the high, low and mid channels based on that information. And that's everything I need to do now for a functioning Donchian channel class. So look at this, I realize I've forgotten one thing in here. I also need to resize the mid array. Alright, that should compile, and that compiles. Now I've just opened the indicator that I used as an example last time. Haven't made any changes to this indicator at all. That still compiles. And now if I go to the chart, and now we can see the new channel is showing, working exactly as it did before. To help with demonstrating the benefits of inheritance, I'm going to create a second channel. This is an ATR channel. Now typically an ATR channel has 5 inputs. There'd be an ATR period, a multiplier which determines how wide the channel is, an MA period that's used to set the midpoint of the channel, a method and a price for the MA calculation. For this demonstration I want to keep this simple and keep it to a single input, the same as we did for the Donchian channel. So I'm going to use some defaults. I'm going to input the ATR period, but I'm going to default the multiplier to 1. The MA period will be the same as the ATR period. The method will be a simple moving average, and the price will be the closing price. In future videos, I will add more inputs and show how we can use those. Now let's create the class for the ATR channel. We already have a channel base class and the Donchian channel class, so the easy thing will be to simply duplicate the Donchian channel and make the changes we need. So first change will be the class name. And then I'll change the Donchian periods to ATR periods. And then I'll change the Donchian periods to ATR periods. Now most of the work is already done. We're already including the channel base. It inherits from the same CCI channel base class. Although I'm keeping this simple at the moment, I'm going to have a single input for ATR periods and default everything. I'm still going to create variables to hold the remainder of those inputs, and that will help with extension later. The update values function is the same. Constructors are the same for the ATR channel as they are for the Donchian channel. I'll change the default value to something more applicable for an ATR. Nothing here changes. Here I'm going to initialize the other default values or the other input values for the ATR channel. So my multiplier I'm defaulting to 1. Moving average periods the same as the ATR periods. Method simple moving average and using the close price. Then the update values function here is obviously going to be quite different for the ATR. The mid channel is just the moving average using method and applied price. The ATR value is a simple function, and then the channel high is the midpoint plus ATR by multiplier, and the channel low is midpoint minus ATR by multiplier. And that is everything that I need to do to create an ATR channel, largely because of the benefits of inheriting from the channel base. Now, just as I did last time, where I created the example application to show the Donchian channel, I'm going to create a new example to show the use of both channels. I'm going to do that again by copying the existing, so I will just set that up. Now I've added a mid channel, so first thing I'll do is increase my number of channel buffers to 3. Then I'll update my indicator values, and I've also grouped each indicator's properties together. So this will be the new mid channel, high and low channel. I also now have 2 channel indicator classes, so I need to include the files for both of those here. I'm going to allow a choice of channel in the inputs. So first thing I'll do is create an enum, which will allow me to differentiate between the 2 channels chosen. Then I add an input for the channel type using that enum. I've added a mid buffer, so I just add 1 extra buffer here, and I'm going to redefine the locations of the buffers. Then here, where previously I defined a variable of type Donchian channel, I'm going to define a single channel variable of type channel base. Because as far as this application is concerned, it can deal with the common information in channel base. I'll just update these settings now to include the mid buffer. Now here, where previously I created a Donchian channel variable of type CCI Donchian channel, I'm now doing a switch based on the input of the channel type, and if it's channel type Donchian, then I create my channel variable as CCI Donchian channel. Now remember, channel here is defined as channel base, but I'm creating instances using the specific channel classes. Here, the only change I need to make is to include the mid buffer, and also because I've changed the variable to channel rather than Donchian channel. And that's everything to create a new indicator that will show either a Donchian or an ATR channel. Let's just switch to the chart and see how that looks. Here's the Donchian channel, and if I change my inputs, change the type to the ATR channel, it now displays an ATR channel. This shows the basics of using inheritance and multiple classes having a similar interface. It gives you some idea of the benefits of inheritance and how it can make your programming easier. I've also tried to demonstrate something of the power of using base classes in your code. We'll continue to expand on this in our future videos. For now, you can download the code that we used here from the Orchard website. I've included a link in the description below. If this was helpful to you, please click the like button and remember to subscribe and click the bell icon to see future